Alright guys, so here we are. We continue on with separations obviously, and we're going to talk today about solutions. We're going to start off with solutions. So what's the point? Basically, you want to look at vocabulary again surrounding solutions, so we're going to be a bit more specific. We're going to understand the components of solution mixtures. Now again, a solution is a particular type of mixture, and you're going to understand how to identify solutions from other mixtures. Alright, so what are the components of a solution? Basically, solutions are homogeneous mixtures where one substance is dissolved into another. Alright, so the solvent. Solvent is the main component of a solution and it does the dissolving. If you look here, that one there is water and that's your solvent. The solute is this stuff here, which is copper sulfate, and that is the minor component that's being dissolved. Now, the way to look at it is here we have sugar. When sugar is dissolved in water, so the sucrose or sugar is the solute, the water is the solvent. If you put them together, you've got a solution. Don't worry about the concentration part, that's for tomorrow. So, yeah, that's our components of a solution. Right, how do you identify a solution from other mixtures? There are several steps. No particles will be visible. It will look as though it's uniform throughout because it's homogeneous. It will have a clear look. Generally, there are some other ones that not quite so much, but we'll say for start off, it's clear to look through, clearish. You can see through it. So if you go back here, down here, it can be very, very dark blue, but still kind of clear. For example, here we have potassium permanganate, which is a fairly dilute. Don't worry about that one yet. And here we have potassium permanganate as well. They're both the same substance that's being dissolved in, so it's got the same solute, differing amounts, same solute. Now, this one you can see through. This one, not so much, but still a solution. It's got a kind of a clearish look. Nothing will settle at the bottom. That's really important. So you have no sediment at the bottom, and it cannot be filtered, which means if we set up a filtration thing, which we'll do later on, you won't be able to separate it out from the water or the solvent. Okay, so just a quick look at types of solutions. Basically, here we go. If we look at the examples, we've got air. Air is a gas solution with a gas solute, in this case oxygen, and a gas solvent, and that's nitrogen. Okay, here we've got drinks. Your solution is a liquid. The solute, which is carbon dioxide, is gas. The liquid is water. Okay, if we go further, if you've ever had any fillings made in, it'll be done with amalgam, which is a solid solution with a liquid solute, in this case mercury, the metal, and a solid silver solvent. And down here we have a solid solution. So you can have gold or steel, any form of alloy really, or most alloys, and you have a solid solute. So if it's gold, like a gold ring, you've got silver mixed in with gold for the solvent. Okay, solubility. Basically, solubility is the ability of any substance to dissolve into a solvent. Okay, so we talk about it in terms of the most you can have in a certain temperature. So per liter, however much of, in this case, copper sulfate, you can dissolve into water at a certain temperature. A saturated solution is when you've got as much as will fit in as possible at a certain temperature. Now, if you think of saturated when we talk about water, so if you're saturated, your body is holding as much water as it can. If you're doing a saturated solution, the solvent is holding as much solute as it can. All right, so that's it. Enjoy. We'll see you in class.